Hello, everyone. This is Jia. I'm a PhD candidate from Syracuse University. Today, I'm going to present the estimation of infection risk through airborne transmission in large open spaces with different distributions. And we all know that coronavirus can be transmitted through airborne route, which can travel with the airflow and infect more people in the space. And according to the research data, most COVID-19 outbreaks occurred in indoor environments. And we actually collect data from Colorado and Michigan, and we plot the hotspots of indoor outbreaks of COVID-19. And we can know that most outbreaks are happened in long-term care facilities, K-12 schools, restaurants, retail facilities, and offices, and also other spaces. And so we know that air distribution in indoor space is very important for airborne transmission of COVID-19. And also most buildings using mixing ventilation, but indoor air is usually not well mixed. And so this diagram shows the result of infection risk and the reproduction number of COVID-19 in different scenarios in different buildings. And we can tell from the result that the production number in larger spaces are typically higher than the other spaces, which means the airflow pattern in large open spaces is more important. Because in these spaces, there are usually more people, and it's more likely to spread out the virus more quickly and to more people. So that's why this study will focus on the airflow pattern and infection risk in a typical hotel ballroom on the two different scenarios, theater scenario and banquet scenario. So we will use a ballroom in Marriott Hotel in Syracuse as an example. And these diagrams use the layout of the room and also these ventilation settings. So we have 8 diffusers on the ceiling for the space, and also 4 returns also on the ceiling. And for each diffuser, it can supply almost 500 cubic meter per hour clean air. And the diffuser is square, and the supply air direction is it has a 30-degree angle to the horizontal level. And we actually tested 2 different scenarios. One is theater scenario, which has multiple audience sitting in the space, and one presenter is presenting something in front of this audience. So in this study, we just assume there are 120 audience sitting in 10 rows. And for each row, there are 12 people. And there's one presenter standing in front of the audience. And another scenario is a banquet scenario. So we have 12 round tables, and each table serves 10 people. So in total, 120 guests sitting in the space. And these 2 pictures are the examples in Marriott Hotel. And so we did some safety simulations, trying to find out the infection risk and the airflow pattern in these 2 scenarios. And these are the safety settings of this study. So we use very fine meshes in these 2 cases. And we use ANSYS front to simulate the result. And for the inlet flow, we have 8 diffusers, and each diffuser supply 500 cubic meter per hour clean air to the space, and the supply air temperature is 26 degrees, and the direction is 30 degrees to the horizontal. And for the occupant, we set up the surface heat flux as 20.7 watt per square meter, which is from the literature data. And for the proton settings, we actually set up the constant passive source in the breathing zone. The breathing zone is we defined as a 4-inch diameter sphere below the nose, which has a volume of 0.5 liters almost, which is close to the literature. And because we're just focused on the airborne transmission of the virus, so which is carried by the aerosols less than 1 micrometer in diameter. So we just set up the passive source, which means the proton has the same air density as the air. And some more details about the proton emissions settings and the exposure calculation. So because we have 120 people in the space, and then we set up the proton source at each location of people. And then for each source, then we calculate the exposure at all other locations to these pollutants. So which means we are going to have 120 pollutant sources, and for each source, we are going to have 120 receivers. So this will give us over 14,000 data sets of the readouts. So then the pollutant sources are set up at the breathing zone. And for infection risk estimation, we will use the Wells Rayleigh model based on the exposure to the quantum of virus. And the assumption of this study is we just use the constant emission rate equals 200 quantum per hour. And we also use the same inhalation rate, and the exposure time is 1 hour. And this equation is a Wells Rayleigh model for estimating the risks. So here comes some results. And first of all, is the airflow pattern in theater scenario. We can tell that the average temperature in the space is around 23 to 24 Celsius degree, and the air temperature around the occupants in the occupied zone is higher than the unoccupied space. So, which means the thermal plume may have some influence on the airflow pattern in the space. So we can tell from this diagram that the airflow pattern is from the front and the back to the middle of the space, which means from the unoccupied spaces to the occupied space. And from another direction, so we can also know the air flows from the center of the space to the lateral, either left or the right of the space. So there's the airflow pattern for the banquet scenario, which is more complicated and less organized than the theater scenario. We can only know that so the pollutant transmission can be transmitted to a pretty long distance. So which means it can affect the people sitting in other tables. And then we also have the infection probability of in these two scenarios, because we have 120 receivers by 120 infectors, and we can plot the heat map like this. The horizontal is the infector and the vertical is the receiver. We can know the infection risk for each receiver exposed to each infector. So we can know that the highest risk in these two spaces is close to 30% in some areas, like for the banquet in here, in these areas, right? And we can also know that the infection risk in banquets are generally higher than the risk in theater, because the color in the banquet scenario is darker than the color in the theater scenario. So, but from the heat map, we cannot tell too much details because we don't know where does the each people located. And in this diagram, we calculate the average risk for each person, and then we plot it in here. Then we can know that the average infection risk for people who are sitting in the middle of the room are exposed to higher risks. So, and people who are sitting in the back rows and the front rows are exposed to lower risks for, well, that's for the theater scenario. And the presenter actually has the lowest risk. And for the banquet scenario, people who are sitting in this table are exposed to highest risks, and people who are sitting in the back and the front are exposed to lower risks. And that's the result from the receiver point of view. From the infect point, where we can also tell something. So here we just calculate, we want to know who can infect more people. So for the theater scenario, we know that people who are sitting in this area and also in some front rows, and also the infector, the presenter, can infect more people. And so for the banquet scenario, people who are, actually we cannot really tell too much information for the banquet scenario. We can only know that people who are sitting here can infect less people. Then some comparison between the banquet and the theater scenarios. So we, these are the box plot for these two scenarios, and we calculate, we know that the mean, we know that the infection risk for banquet are higher than the risk in theater scenario. And the mean value for banquet is around 2.57%, and in the theater the mean value is around 1.3%, which means the average infection risk in banquet is almost double of the risk in the theater scenario, which is very interesting because these two scenarios actually has exactly the same room layout and also occupant number and the ventilation settings. The only difference is how these occupants are located in the space. So we also calculate the risks using the Westland model based on the well mixing assumption. The result is almost 2.75%, which is close to the result for the Bankrupt scenario, I mean the mean value, and it's larger than the theater scenario, which means if we use Westland model with well mixed assumption, the result may be fine for Bankrupt scenario, but the result may be higher, may overestimate the result for the risks in theater scenario. But that's the result for in average. But in some scenarios, in some cases, the result in some location can be very high. Then for the Bankrupt scenario, we also want to know where are the risks from? Are they from the people who are sitting in the same table or from the people who are sitting in the other tables? So that from the result, we can know that infection from same table are higher, 3.7%, higher than the infection of cross-table infections, 3.7% versus 2.7%. But overall, actually, this difference may not be so significant. And also for cross-table contamination, it may also cause very high infection probability. So remember that from the very beginning, the heat map, we know that the highest infection rates in these two scenarios can be close to 30%. So then we want to know where do the high risk transmission occur. So we just plot the transmissions with infection probability larger than 10%. So we can know that people who are, for the theater scenario, people who are sitting in the middle and sitting in these locations, and some people who are sitting in the front rows and will infect more people. And for Bankrupt scenario, well, we know that the high risk transmission are more likely occurred in this area, in this table, which is consistent with our earlier observations. And actually for this table, the infections are more likely the cross-table infection, right? And for the infections in this table, this table, and also probably this table, the infections are more likely the same table infection. So at the end, we also want to know the risk versus the distance from the receiver to the infector. So we can tell that for high risk transmissions, so it's more likely to occur in shorter distance for both Bankrupt and the theater scenario. And another finding is for theater scenario, so 2-meter restriction may work well because people who are sitting beyond 2 meters are exposed to smaller risks. But for the Bankrupt scenario, the 2-meter restriction may not work very well. So even for people who are sitting beyond 2 meters, the infection risk can be still very high. I guess it's because of the AL in Bankrupt scenario is more mixed. So here comes some conclusions. And that's everything I can present today. Thank you very much. And I'm open to take any questions. And thank you very much.